Okay, we're working today on bench testing a small Gast oilless piston air compressor. This is a series 1 LAA, which is a 1/6 horsepower air compressor. It's rated at 50 psi continuous duty. It's got a 1/6 horsepower motor, full load amp 3.9, and it is a thermally protected motor. It's important to notice the way we've got this hooked up. Unlike a normal air compressor package like you'd have in your garage, would have a pressure switch that would turn the unit off when it reaches its maximum pressure. We've eliminated that so we can do a continuous duty test run on this pump. This pump has just been overhauled. We put a new service kit in it, so we wanted to go ahead and test it at continuous pressure duty to make sure everything's functioning properly. So we've got the compressor fastened down to the workbench with some clamps. I've got the pressure line, high temperature pressure line hooked in, and that's into the 3-gallon air compressor tank. We like to use the compressor tank for a couple of reasons. It gives us a nice place to fasten all of our different accessories, and it also takes the pulsations out of the pressure line so we don't ruin our pressure gauge. You can see in the gauge cluster here we've got a 0 to 100 psi pressure gauge. I've also got a manual pressure regulating valve, which is basically a needle valve. And what that's going to do is it's going to bleed off excess pressure. So that is an adjustable valve. Now it's important to notice whenever you're doing a pressure test such as this, there should be a couple of safety features in line. We've got here on the compressor head itself, there is a pressure safety valve, and also likewise on the tank receiver there's also a safety valve here. And what that does, in the event that my needle valve malfunctions, the safety valve will pop off, relieving the pressure before something else explodes or malfunctions. So that should be a good safe way of doing it. What I've done here is put my clamp meter on the back so we can read the nameplate amps as the unit is running. As I mentioned, it should be 3.9 or less. So we're going to go ahead and start this unit up. Basically plug it in. Now, since there is a 3-gallon receiver involved, it's going to take a few seconds to build up pressure to get up to the 50 psi that we want. You can hear a couple things. The compressors do make a little bit of noise. It's a reciprocating piston compressor, so there is a little bit of vibration and noise to it. That's normal. And also you hear the air hissing, which is my pressure relief valve. So what that's doing, I can go ahead and close it. We'll build up the pressure a little faster that way. So the unit's building up, and as it reaches 50 psi, I can start opening this valve. You can see the needles going up nice and smooth. There's no pulsation, so our tank is working, doing the job, so we're going to save that gauge from premature malfunction by doing it this way. So we're right almost up to about 50 psi, so I'm going to start opening my valve so we can level off right there at about 50 psi. Okay, so now this air compressor is continuous duty. It can run at 50 psi like this indefinitely. It's designed for that function. You can run it on a tank where it cycles pressures and then shuts itself off. But in a situation where a guy maybe wants to aerate a plating tank or a deep pond or something, he may want to run this thing 24 hours or 8-hour shift, and it is designed for that. The pump itself has a cooling fan, so it's drawing air on this side, pushing it past the compressor motor, so it's cooling it off. Like I said, there is a thermal protection. I need to back this down a little bit. We're getting a little too much pressure here. about 50. What I'm going to do is come over, turn on my clamp meter, and we're running right around 3.75, 3.76 amps. Nameplate maximum 3.9. So we're right where we should be. So what we're going to do is go ahead and let this unit run once we dial in our 50 pounds and get it kind of set there. We'll go ahead and let this run for a half hour. Basically what we want to do is make sure that we run it at maximum pressure. We want to run it for about a half hour, 45 minutes. Make sure the unit gets up to full temperature. It's going to show a little heat on the compressor head like I feel here. That's normal. That's physics basically, or you've got the heat of compression going on there. But we also want to make sure that we run it at maximum pressure for an extended period of time to make sure that the electrical motor is not malfunctioning. There is a thermal protector in this unit, so if the pump should overheat and the motor thermals will kick out. So it is an automatic restart thermal, but we want to make sure that we can run this unit for a good at least half hour, 45 minutes, bring it up to temperature without anything tripping. So that's basically what we're doing here. We're going to let this unit run, and as the way it looks to me, everything's running just fine, and we should be good to go. We'll get this unit packaged up and shipped back to the customer.